Hello everyone, my name is Carlos Olivas and welcome to my real world static analysis project for statics. In the real world, we see static structures every day, from buildings and bridges all the way to stop signs and benches. And it's important that these structures don't malfunction. I mean, what will happen if for some reason a bridge collapse that will result in a lot of injuries and deaths. So that's why engineers need to design these structures under real conditions, such as in this case wind loads, which is the main focus of our project. This presentation consists on basically the most important information that I gathered from this project. So here, as you can see, we have the table of contents. We will first be talking about the objective, then we'll see the free body diagram of my structure. Once you get a hang of my free body diagram, we'll analyze the steps into solve for the support reactions, and finally, you'll get to see the result. But first, we need to know why this project is important and why are we conducting it and why it's important for mechanical engineers to get a grasp on these concepts of static equilibrium. So the main purpose of this static project is for us UTEP students to learn how to apply static analysis on a structure, for us to learn how to conduct a 3D free body diagram and how to understand the forces that are acting on it, as well as the moments, and to analyze how wind loads affect this structure. And as you can see here circled in red, I chose a lamppost which is outside my house, to research this project. So now that you have a background on why this project is being conducted, let's really start with the important part. So first, let's see the free body diagram. So here on your right, you can see a free body diagram which has 6 unknowns, 3 forces which are on the x, y, and z axis, as well as 3 moments which occur on the x, y, and z axis as well. And since the lamppost is composed of 3 main components, which is the main post going upwards, the cylinder which is attached to the top, and the head of the lamp, we gather 3 weights which are acting as downward forces that you can see on the diagram. And to the top left of the diagram, you can see the values for each of the weights. So now let's dive into the step analysis so you can get an understanding on what I did to solve this structure and its support forces when wind load is applied. On this slide you can see the equations that we will be using throughout the steps in order to get the weight of each of the components, which you already saw on the free body diagram, but are necessary for us in order to complete the support reactions. So now that we know the equations we will be using to get the weights of each of the components, first we will need to analyze the dimensions and materials. Measurements such as height and width of each component of the structure, as well as researching for the densities of the materials, which in this case are steel and plastic, which are the 2 materials that form the lamppost. Now that we have all our dimensions and densities, we can use these to calculate the volumes, which so now that we have all of our masses, we will multiply each of them times gravity acting on Earth, which will give us the weight of each of our components acting on the lamp, as you can see here to your lower right. Now that we have these weights acting on the light pole, we will now need to calculate the wind load force applied on the body, and this is done by using a wind load calculator on the internet and using the area of our body to get the force that will be applied. Once we have the wind load force, we will use the sum of forces and moments to solve for the unknowns, and thus leading to the result of the project. So finally here we can see the results. From the sum of forces on the y-axis, we can see that the force applied on the y-axis is equal to 5,222 newtons. From the sum of forces on the z-axis, we have that the force applied on the z-axis is equal to 2,847 newtons. And from the sum of forces acting on the x-axis, we have that the force applied on the x-axis is equal to 0. So in conclusion, after applying the wind load to the body, we came to the conclusion that this structure is under static equilibrium due to the amount of support reactions that it receives. Lastly, I would like to thank you for your time. I hope you understood this presentation, and here finally you can see my bibliographical references. Once again, thank you for your time, and have a nice day.